In this video, we're going to talk about the two different kinds of analysis you can do in the Safer Streets Priority Finder. So the first type of analysis you can do is a sliding window analysis, and this looks at the density of crashes on your network over the past 5 years. And so it's only looking at historical crashes that have already happened. It's not looking at anything predictive or systemic, and this diagram in the overview tab shows you kind of what it's doing. It's taking a little half-mile snapshot of the network and looking at the density of crashes and measuring it there. And then it's taking a little baby step and measuring the density along the next half mile and on and on. So at any given segment in the network, you're seeing the density of crashes happening along a line in a corridor. And that's really useful because it can help you pick out patterns that you might not see if you were looking at a simple hotspot analysis. Crashes tend to happen in corridors along roadways with similar characteristics. And so this helps you find those corridors where the greatest crash densities have occurred. As I mentioned, this is only looking at historic crashes that have already happened, so it's not helping you proactively target areas that haven't seen crashes yet, but it's still a really useful tool. And you can run this analysis for bicyclist crashes, for pedestrian crashes, and for any other mode. So if you wanted to look at all motor vehicle crashes, you could categorize those as other when you're loading your data and see more of these are along freeways. If you wanted to look at motorcyclists or transit vehicles or some other unique subset of crashes, you can use this other field when you're loading your crash data to do that. There are a few caveats to this. The big one is that a lot of cities digitize their roads where it's a divided road as like two parallel lines. Let's see if I can zoom in and show you one of these here. So this is one road, but it's got lines in the network for either direction. And so that means crashes happening along this road are only being assigned to half the road. And so it's twice the mileage, and it may be underestimating risks. So here we have this divided road with already kind of a medium or high level of crash density showing up from our analysis. You can assume that it may actually be higher because the divided road is making it look a little lower than it is. And we've documented some of these things in the frequently asked questions. There's how the analysis works, how it fits into bigger picture. And so there are a lot of different caveats in here that are important to be mindful of. See dual center lines that it may underestimate. That's what we're talking about with these two lines for divided roads. The other analysis that's built into the tool is the Safer Streets model. And so this starts with something similar to the sliding window analysis. It's still looking at crash density on a network, but then it's layering in additional information from a national model of pedestrian fatalities at the census tract level, as well as some background information on national rates of crashes by mode and functional class, fatal crashes, I should say, national rates of fatal crashes by mode and functional class. So on a major arterial, for example, the model is using both the number of and density of crashes that have already happened there, as well as information from this pedestrian fatalities model and information coming from the fact that it's a major arterial. And so this is useful because we know that crashes are statistically rare. They're far too common, but especially for vulnerable road user crashes, there are places in your network where if no one's walking or biking, you're not going to see any pedestrian or bicyclist crashes. And that doesn't mean that your network is safe there. It just means that there's no exposure, so there are no crashes. And so this model can help tease out where some of those places in the network might be. And you still need to use your engineering judgment, go in and look at these locations, see if there are common risk factors present on the ground, really see what they look like. But it's a useful way to start looking at your network through a systemic lens without having to have just tons and tons of roadway data. The Safer Streets model is, it can help fill in gaps where there aren't a lot of crashes, but its performance in areas where there haven't been many crashes at all is still being validated. So if you're running this model in like a smaller town or in a rural community where there may have only been 5 or 6 pedestrian crashes over the past 5 years, the model results are still, we're not super confident in those yet. So go ahead and use the tool and look at the data that comes out, but combine it with your local knowledge, with your understanding of what's going on the streets, to make recommendations and prioritize future improvements. So you can see with the Safer Streets model, there's a methodology section in the overview methodology tab that talks about what the model is doing and where some of the different data sources are coming from. There's background information on the different additional pieces of information we're adding in. We convert the outputs of that model into a cost on your network, a cost rate per mile. And so there's information on the assumptions we're making and how to interpret those values and what the additional data sources are. So definitely read the methodology so you understand what we're working with this model. You can actually go into the, sorry, not the dashboard, I want the map visualization tab, and see what some of these underlying inputs actually are. So let's turn on the pilot tool model. This is that National Pedestrian Fatalities model that we use to inform the Safer Streets model. And let's turn on pedestrian crashes and we'll look at the model output for pedestrian crash rate. And you can see how those coincide and how this model is giving us a better look at safety. While that's loading, I'll say you should also check out the frequently asked questions, because that gets into a lot of the specific details of what to be mindful of with the model, like the dual centerline problem, making sure you have the right number of crash history. So here, the shaded polygons are the pilot tool model that's estimated at the census tract model or at the census tract level. And so you can see this census tract here is really large and the estimated number of pedestrian fatalities is very high. But when we turn that layer off, we can see like there actually aren't that many roads in the tract, and where the crashes seem to be happening is along this road on the boundary of the tract. And so what our model is doing is taking what the pilot tool is saying, as well as your crash history, and helping us understand what that distribution of risk really looks like. Because without our additional information, we just see, oh, well, the risk is high on this side of the line and it's low over on this side of the line. What does that mean when the road is the boundary? So we can see it actually is this road that is likely contributing most of the crashes and most of the risk to that census tract. So it's helpful to get that more granular view of things. What else is important to know? The FAQ has some really important information on how to interpret the model in places where there haven't been any crashes yet, or in rural areas, dual center lines. So read through this to really understand where and when and how to use the model outputs. There are model fit charts in the data dashboard. The model itself has been calibrated so that the total cost of crashes by mode that your input data had over 5 years should roughly match the total cost of crashes that the model's putting out, but you can still see how the distribution by severity and mode matches. So we can see we're kind of overestimating fatal crashes and underestimating lower severity crashes in our models. And that's that little bit of overestimating fatal crashes has a big impact on the cost output of the model. But this is just a good way to get a feel for how well that base model is fitting your data. And there are different ways of looking at the outputs. You can look at top 10 window segments. You can also actually download the results yourself and play with them. If you're a GIS user, you can download a shapefile with all those scores on the network and look at them in a sub area along a corridor, whatever works for the project work that you're doing. Thanks.